Hello everyone, and welcome to this lecture on job types overview. So we're going to categorize job types in programming into 7 different categories. Those are infrastructure, backend, front-end, native, science and theory, marketing, and then finally hardware and graphics. So one thing to note is that there's definitely overlap between the skills required for each of these positions, and even some titles will overlap between categories. So just keep that in mind. First up, infrastructure. So there's sysadmin, which is a position where you manage, set up, and keep systems running. And then there's also DevOps, where you create and use tools that developers use to manage systems. There's also network engineering, setting up, designing, and optimizing network infrastructures, as well as data center operations, who basically keep the cloud running. Along with that, there's also cable and router technicians, database administrators, and then technical support and documentation staff, who actually have to interact with customers and users. Then there's backend. So there's quite a few positions here. There's full stack engineers who do a little bit of everything, backend application development, who use things such as Rails and Django, so Ruby and Rails, and then Python for Django, Node, etc. There's also project management, which isn't always a technical role, and then there's engineering management, where former developers usually get hired into a management position. Just keep in mind that the terms product management, project management, and engineering management may mean different things at different companies. There's also software architects who plan out features before they're actually coded. There's also API design, where you design interfaces between systems. Security and penetration testing. Distributed system architects, who deal with consistency, availability, partition tolerance, timing of large globally separated systems. And then there's also database administrators. Then the front end. So the front end, there's full stack engineers who again do a little bit of everything, but they're focused primarily on the pieces that support a front end of a website. So then there's UX and UI front end designers who deal with Photoshop, InDesign, Sketch, HTML and CSS, etc. That's their piece of the pie there. Then there's general front end web development, so HTML, CSS, and JavaScript. Single page app development, so those are people who mostly deal with JavaScript frameworks such as Angular or React. Then there's also quality assurance and testing, so you write tests, do human tests, make sure things actually work. Then the next category is native. So these are people who develop in iOS or Swift, Android, Windows Mobile, etc. They also work on consumer-facing Windows desktop applications, OS X desktop applications, and even Linux app development. There's also enterprise software development, so large made-to-order applications for businesses, IT administration and admin software design. These are often very system-specific, hence they go under the native category here, and also software architecture, similar to that backend architecture role where they design features before they're actually coded. Then there's the science and theory category. So there's scientific research. These are people in academia who use MATLAB, R, and IPython and more, those kind of things. There's also pure computer science or pure math roles where they research with Haskell, Lisp, and lots of other languages. There's scientific software development. So for instance, there's some companies working on protein folding software, a lot of biotech companies. There's just a general term, data science, which is what I do personally, which again is MATLAB, R, IPython, scikit-learn, etc., and machine learning, which also falls under data science. Then there's OS design, which isn't just Microsoft, Windows, and Linux, but also things and companies such as Qualcomm and lots of other telecoms hire tens of thousands of engineers to write embedded and mobile operating systems. There's also marketing, which has a lot of crossover with data science, but terms like growth hacking or web scraping, where they use Selenium, Beautiful Soup packages for Python, Phantom.js, scikit-learn, which is a machine learning package for Python, Pattern, etc. There's analytics, so you can use Mixpanel, Optimizely, etc. This is also closely tied with marketing and SEO, search engine optimizations, and then just general marketing development, things such as Salesforce, analytics, content design, and again, search engine optimization, SEO. Finally, there's hardware and graphics. So there's embedded software. This is known as code that runs very close to the metal, such as the assembly code running an elevator. There's also chip design and architecture. There's game development, which a lot of people feel is much different than normal development, so just keep that in mind. And there's also graphics software development. Sometimes there's crossover between that and game development. Then there's 3D printing and machine coding. And then there's CGI and animation. All right, I know that was a ton, so you can go ahead and check out the resource link at this lecture for this PowerPoint presentation so you can look over the positions slowly on your own time. But in conclusion, most engineers and programmers have skills in multiple categories. So just think about what interests you as you go on and continue throughout this course. All right, thanks everyone, and I'll see you at the next lecture.